Okay, guys, so an inverse just reverses the order of pairings of a relation. Like you literally just switch the place of x and y. That's how simple it is in the beginning. So if I have a point of 3, -5, its inverse is -5, +3. You just switch them. So I'm going to highlight right here where it says x and y change places because that's all that inverses are. If you notice, we also have some new notation here. That f to the -1 of x, that stands for an inverse. Every time you see that, that's just an inverse. That's all that means. All right, so let's go ahead and start talking about what an inverse is. Let's look at example number 1. Example number 1 says, find the inverse of g of x, and then it gives us these ordered pairs right here. And remember, based on this information, what we're going to do with these ordered pairs is just switch the place of x and y. You keep the sign, you just switch where they're at. So if g of x has -1, -2, then the inverse is -2, -1. You literally just switch them. The next ordered pair is a -3, +2. We're going to write 2, -3. And then our last couple of ordered pairs is going to be 4, -5. And then our very last one is going to be 8, 2. So this is the inverse. I know that this is the inverse because it has that -1. -1 exponent always means inverse. I'm just going to separate these with a comma and then put those braces back around it. All right, so for number 2, what we're going to do is we're going to graph that equation. We're going to graph its inverse, and we're going to graph the line y equals x. I'm going to go out of order. I'm going to start with graphing this line y equals x. First of all, this line is so special it has its own name. Does anybody know the name of that? All right, write this down. It's called the linear parent function. And that's y equals x. And guys, listen, I'm not going to test you on that, but I have seen SAT questions with those words on there. So if you got to take the SAT, if that's coming up, if you see the words linear parent function, that means that line. So let's talk about this line. This line goes through the origin because it doesn't have a y-intercept. There's no plus or minus behind it. And y'all, what's the slope of that line? What is that slope understood to be? It is just a 1. So y'all, what I'm going to do is I'm going to graph this. And y equals x, it cuts the graph in half on the diagonal. So I'm grabbing my straight edge. I'm going to cut this graph in half diagonal, but it has to go through the origin. Don't draw a solid line. Draw a dashed line with your red pen. This is going to be the line of reflection. So just kind of making this happen here. Please do not forget to put arrows on your graphs in Algebra 2 and for whatever higher math class you're taking. We also label everything, y'all. So after you draw that dashed line, write y equals x. All right. The next thing I'm going to do is I'm kind of going out of order. Now I'm going back to the beginning. I'm going to graph 2x plus 4. So for 2x plus 4, you guys should know how to do this. The y-intercept is plus 4. So I'm going to go 4 places above the origin, draw my dot, and then use my slope, y'all. Remember the slope's down to or up to over 1, up to over 1. And I'm using a different color from what I did for that y equals x. So there's my y-intercept, 1, 2, 3, 4, and the slope is 2, so you go up to over 1, put a dot, up to over 1. I'm also going to go in reverse, guys. I'm going to go back to my y-intercept, and I'm going to go in the opposite direction, get a couple of points that way. So I'm going to go down 2 over 1 a couple more times over here. So if you notice, I got 5 dots on my graph for that line. I'm going to connect them now. Use your ID or a straight edge. Make it neat. Line up your dots and connect those. This time we're going to connect with a solid line. Draw your arrows. And again, we label everything. Y'all, we're going to label this f of x. Right? F of x. All right, so the last thing I need to do in this sentence is graph its inverse. The way we're going to graph the inverse is we're going to take these ordered pairs and switch their order and plot the new dots. That's why I asked you guys to have like those extra ordered pairs on the line. So the first ordered pair that I see is right here, that x-intercept. That x-intercept is -2, 0. Switch the spots, y'all. So I'm going to plot 0, -2. Let's see. This ordered pair right here, I think that's a -1, +2. So write +2, -1. Remember our y-intercept right there at 0, 4? That's going to become an x-intercept. So write 4, 0. The next ordered pair is at 1, 6. So please write 6, 1. The last ordered pair that I have on my graph is +2, 8. So let's write 8, 2. Bless you. Okay, guys, I'm going to plot those ordered pairs and connect them. So here I go plotting the dots. Okay, guys, so now that we have that, those are the new dots. Y'all connect them with a solid line. And y'all, please label this with the inverse. Hang on a second, I got you, hang on. For this next one, let me adjust my screen a little bit. Now what we're going to do is we're going to ditch the graph, and now we are going to solve using algebra. So what we're going to do is we're going to take this function and find its inverse. And y'all remember, the inverses are always about switching x and y. So I'm going to rewrite this. I'm going to drop the letters f of x. I'm going to write this as y equals, because remember, f of x and y equals are the same exact thing. And this is 2x plus 4. And then I'm going to swap x and y. So on the next line of my work, I am literally writing x equals. I'm going to recopy that too. But now y is over here next to the 2. And everything else stays the same. So to find the inverse, I got to solve for y all over again. So guys, if you notice, I've got 2y plus 4. I got this plus 4. I'm moving that to the other side. So remember, when you move something to the other side, what happens to the sign? It switches. So the next line in our work is going to be x minus 4 equals 2y. And then the y isn't by itself. It almost is. What can I do to make that y by itself? We have to divide. If it was plus or minus, we would move it. But if they're stuck together, we have to divide. So y equals x minus 4 divided by 2. And that is a 100, that's full credit. However, there's another way to solve it, and it looks a little different. So if I'm doing this stuff and I'm taking like a multiple choice quiz or a test, I need to be able to see all the different forms of it. So what I'm going to do, let me kind of shift color so it stands out. I'm going to go back to this step right here, and I'm going to show you an alternate way to solve that. So let me go back to x minus 4 equals 2y. So here we are again. We're about to isolate y. Instead of dividing by 2, what could we multiply by? What could we multiply by? What would make a 2 go away if we multiplied by something? 1 over 2. Good job. Whoever said that, housemate. We're going to multiply both sides by the reciprocal. Always by the reciprocal. So now, we're going to distribute that 1/2 over there on the left side. So now it's going to look like 1/2 x, and then y'all, what's 1/2 times a negative 4? Negative 2, thank you. And that's going to equal y. There's 2 ways to solve. You have to know both ways. So listen, for me in here, this is the form that I'm going to use, because y'all, that's slope-intercept form. So I'm going to rewrite the letter y. Remember, it started out in function notation, so we have to write that weird symbol now. And I'm going to recopy this. So the inverse is 1/2 x minus 2. So the steps right there are in that text box. I even put a box around it. You're always going to use that right here on these notes. All right, so look. Guys, look at your graph. That's a -2 for a y-intercept. Is that a -2? Why, yes, it is. And the slope for here is up 1 over 2. Would you go up 1 over 2 to go to the next point on your line? Why, yes, you would. So all of this is consistent. So I'm going to box in my f of x, because that's going to be the inverse that I'm going to use. We have to prove that they are indeed inverses of each other. And the way that we're going to prove it is we're going to use compositions. So remember, yesterday I told you, when you have this setup right here, whichever function is listed second gets dumped into the first. So remember, the first function that we've been dealing with on this whole page is 2x plus 4. So 2 times x, look how I'm writing x, 2x plus 4. Remember, that was the original function from right up there, y'all. I was looking right there. 2x plus 4, 2x plus 4. But I did not write the letter x. I saved some space because the inverse is going in there. What is the inverse? That right there. So 1/2 x times minus 2 goes in here. All right, so here's the deal. We're going to distribute. We're going to combine like terms. And the only way that we can prove it's a function is if we just have x. So down here, everything has to get wiped out except the letter x. So let's see what happens when we do this distribution. So y'all, was 2 times 1/2. So write an x, good job. And 2 times that -2? Yep. And then y'all don't forget to bring that plus 4 down on your next line of your work. Y'all, what's a -4 and a +4 made? 0. That's a 0 pair. What's the only thing that's left? If you don't end up with x, we did it wrong. So that's perfect. That's exactly what we want. So this is proof number 1. And guys, draw a little bubble around that because we have to do it all over again. Okay. So for the next one, this time I'm going to switch the order, guys. This time I'm going to take the inverse, which is 1/2 x minus 2, and I'm going to dump in the original for the letter x. Watch how I write this. So I'm going to write 1/2 parentheses for the letter x minus 2. What goes in parentheses? The original equation. So we're going to put in 2x plus 4. Again, down here at the end of my work, if I don't have a plain x, I did it wrong. I made a big mistake somewhere. All right, so we're going to distribute 1/2 times 2x. That's just 1x. Y'all, what's 1/2 of 4? Right, plus 2. Bring down your minus 2 from your previous line of work. Guess what happens? Everything gets wiped out except the letter x. So this is proof number 2. You have to do it twice. You have to do it twice. Once is not good enough. You have to do it both ways. Do you guys have any questions on that? When you move the 4 over to the other side, you get x plus 4 because it moved. And then the 2/5 y stays the same. Remember, at the beginning of the class period, I showed you how to multiply by the reciprocal. I wasn't doing that for fun. I knew that you would end up having to do this like 3 or 4 times. So we are going to multiply both sides by the reciprocal of 2/5, which is 5/2. And then you're going to distribute. So this is going to leave just a single y. Those cancel out. And then we're going to distribute 5/2 times x. That's just 5/2 x. And oh my goodness, here's something else I told you in the beginning. We practiced how to take a fraction and multiply it by a whole number. You should be able to do that in your head. What is 5/2 times 4? What? It's a 10, that's right. Let's write 10. That's the inverse. So I'm just going to write the inverse over here. I'm going to use my function notation. And now I'm going to prove it. I got to prove it twice. If I don't prove it twice, I'm not getting credit. All right, so now what we're going to do is we're going to take the original and we're going to put the inverse in there for the letter x. So remember, the original, I'm just going to use the form where I put the x out to the front. It's going to be 2/5 times x. I'm leaving some space there, minus 4. And what is the value for x? It's the inverse. So we're going to put 5/2 x plus 10. What's 2/5 times 5/2? What's that? 2/5 times 5/2. That's just 1. So when we distribute, that's just an x. When we distribute it to the 10, that's 2 times 10, which is 20. 20 divided by 5 is a positive 4. Bring down your minus 4, and then that's a 0 pair. So you just halfway proved. You halfway proved that that was going to be an inverse. All right, let's go ahead and write proof number 1. And then we're going to do it all over again. But this time we're going in the opposite direction. This time I'm writing what I have in orange first. So it's 5/2 x, but don't write x. Give yourself some space to fill in something for x, and then write plus 10. So, what goes in for x? The original. What is the original? It's over here. That's the original. See how there's not a minus 1 at the top? That goes in here. So, I'm going to write in 2/5 x minus 4. Okay, so just like 2/5 times 5/2 went away on that side, 5/2 times 2/5 goes away on this side too. So that's going to leave a single x. And then 5/2 times that -4, you guys have got to get that down. 5 times a -4 is a -20. -20 divided by 2, -10. Bring down the plus 10. That's a 0 pair. X gets by itself. That is proof number 2. And that's how you find compositions and prove that they are inverses of each other.